Hi everyone, I'm Julia from Krannich Solar. Thanks for joining our webinar today with SolarEdge. Before we get started, I'm just going to give a quick presentation about Krannich. Krannich Solar is headquartered in Germany and was founded by Kurt Krannich. Since being founded, Krannich has expanded into 26 different countries and can ship to over 100 countries. As a privately owned and self-financed company, we hold a significant market share and rank among the leading solar wholesalers globally. With 29 years of experience in delivering solar products worldwide, we've become experts in the field. Our international purchasing power helped us build strong relationships with your favorite manufacturers, such as SolarEdge, to secure the best pricing and availability. In 2005, Krannich expanded into the U.S., opening our first branch in New Jersey. Today, we have branches in California and Florida, and we've expanded into Texas with additional warehouses across the nation. Our U.S. team consists of over 80 employees that service the Americas and strive to offer the best services and options to our partners. We are growing every day, so keep an eye out for where we might be next. Krannich is a top partner for installation companies seeking PV system products. In our role as an internationally operating wholesaler, we can make a significant contribution to shaping the energy transition. With every PV system we supply, we come closer to the target of carbon neutrality and fulfill our mission of paving the way for 100% renewable energies. Our company values are the drivers of our success and our inspiration in a dynamic market. Throughout the years, we've grown our product portfolio to provide over 5,000 products. We've partnered with leading manufacturers worldwide to offer the best materials for a project of any size, whether it's an off-grid system, 4-panel shingled roof, or a megawatt flat roof. Choosing Krannich means you'll never work alone. Our streamlined ordering process ensures that customers receive a dedicated sales rep guiding them through every step, from project design to on-site delivery. The solar industry is always innovating and changing. At Krannich, we're committed to keeping you informed about the latest products and technologies. We collaborate with industry leaders and seasoned professionals to offer first-hand training and everything you need to know. And it'll always be for free. And this concludes my portion of the webinar. Here's our contact info if you would like to reach out for a quote or if you have any questions regarding the products or services we offer. And if you have any questions throughout the presentation, please feel free to ask them using the question box and they will be answered at the end of the presentation. Thank you again for joining us. And now I'm going to pass it along to the team from SolarEdge.
Hey everyone, I hope that you can see my screen, and thank you, Julia, for the introduction and for inviting us to hold this webinar about Agri-PV. I just want to make sure that everyone can hear me and that you can see my screen. So if there's just a way for you to signal that it's all working well, that would be great. Okay. Okay, so I do hope that you can see my screen and that you see the presentation fully. And I'll just start. And again, if there is any issue with the broadcasting or the presentation, just let me know and I'll fix it. So we'll talk today about Agri-PV, and we'll talk about SolarEdge and SolarGik solutions for the growing Agri-PV market. I'll do the first part about the overview and introduction of SolarEdge and Agri-PV. And together, I have two of my colleagues today that will be speaking after me. First will be Chiranshu Bhatia, field application and engineer SolarEdge, and Mo Horowitz from Solargik, Chief Commercial Officer at Solargik, will have a presentation and discussion about the Solargik smart tracking solution for Agri-PV. We will start my part in this presentation by introduction to SolarEdge, about the company and what we do. Then I'll give a short overview and explanation about what is Agri-PV and what are the main global drivers that fuel the growth of this segment. I'll show also a few examples of policy, regulation, and incentives from around the world to give some understanding about how an Agri-PV market structure basically looks like. And then we'll talk also about what we in SolarEdge already do in Agri-PV. We'll show examples from our Agri-PV portfolio, and then we'll talk about our experience, why and the need for DC optimization in Agri-PV projects, and to really achieve the benefits of dual use and Agri-PV. After that, Chiru will discuss our SolarEdge solution for ground mount and dual use applications. And as I mentioned, Mo Horowitz will present SolarGik and also conclude this presentation. So before I start, just some facts and figures about SolarEdge. For those of you who are less familiar with what we do. So SolarEdge is a global leader in smart energy production, storage, and management. We manufacture and develop solutions for producing solar energy from hardware to software, from solar energy production to site management. And we have offices in more than 36 countries around the world. Our products are installed in more than 140 countries around the world. And globally, we have more than 5,000 employees. One thing that is important for this presentation, because we're about to talk about the DC optimization solution and the need for DC optimization for Agri-PV. So I really want to emphasize the fact that SolarEdge is the company that invented the power optimizers. This is the solution, the first thing that SolarEdge started with, and to date we shipped more than 106 million optimizers around the world. So this is really important for this presentation. And I'll now give some background and overview about global drivers in Agri-PV and what really makes or why Agri-PV is growing rapidly around the world. What are the drivers and what do we see? So the first thing that really makes Agri-PV needed, and just before I start to talk about the drivers, I'll say that when I say Agri-PV, I mean the dual use of land for both solar energy production and agricultural production. Same land used for two land uses. And this is very much required because as you can see, globally, we see a trend of more and more ground mount solar projects that are being installed on farmland. You see, for example, that in the US, 83% of new solar projects are planned to be installed on farmland. By the way, 50% of these will be installed on the most productive farmland in the US. And in the EU, in order to achieve the European Union solar energy targets, the European Commission announced that 50% of the capacity required for achieving these targets will be installed on farmland. With that, we understand that there is a problem, because if we don't do dual use, it means that these projects will basically replace farmland, and obviously we do need this land to produce food. We add to that the fact that farmers around the world really suffer from the climate change impacts, really find it more difficult to produce food. So they are more willing to give up on farming, and they are more willing also to sell the land. Again, this is something that creates a lot of challenges, especially from the eyes of policymakers. And it also increases a lot this public opposition to solar, because with this idea, suddenly there is a lot of public opposition, there is a lot of community protest against solar installations on farmland when it's not dual use. And these three drivers are really important to understand why Agri-PV is such a growing market, and why all over the world we see more and more regulators, policymakers that push, incentivize, and really fuel the growth of this segment. We see here just few examples of already existing Agri-PV markets: US, France, Italy, Croatia, Germany. These are just a few examples of market countries that already regulated and also in the process of regulating rules, incentives for Agri-PV. On the right, we also see the growth. So we talk about 14 gigawatt in 2021. That was the last time that there was an official publication of the Agri-PV capacity, and growth in this will be the projected growth will be 37 gigawatt in 2027. I must say that recent figures shows that these estimations are quite conservative. We see that currently in the EU there are more than 200 Agri-PV sites with 2.4 gigawatt capacity, and in the US, according to data published by NREL, there are more than 10 gigawatt in Agri-PV projects. So just to understand, Agri-PV is no longer a niche market, is no longer something that is just being done for research purposes. It's a really significant solar market. I would say that in many markets that we operate in, it's becoming the dominant form of ground mount solar. And we see also the growth in terms of the dollar value from $2 billion in 2023 to expected $15 billion in 2033. These are very recent figures that were published last week. So when I say that policymakers push and fuel the growth of Agri-PV, here I want to give some examples of how Agri-PV regulation, or what is the regulatory structure for Agri-PV. And I think that it's very important, not just because it's interesting, not just because it really shows the opportunity and the financial opportunity. It's also important because what we see here, basically, before I dive into the details in this slide, is somewhat sticks and carrots that are being provided by policymakers. So on the left, we see the financial incentives. For example, the Italian government provides 1.7 billion euros for funding Agri-PV projects. They are willing to give up to 40% of system costs to systems that can really show that they are eligible to get these fundings. We also have other feed-in tariff bonuses like the SMART program. We have federal budget for R&D research, $75 million in the next 5 years, so it's $15 million every year. And we have a lot of funding for research and for incentives for commercialization of Agri-PV. On top of that, still in the carrots part, easier permitting is another tool that policymakers use in order to promote Agri-PV. In many markets that we operate in, we see that Agri-PV gets easier permitting, faster process for permitting. It's something that policymakers and authorities are more willing to accept, again, due to the drivers that I presented in the first slide. So a lot of developers, and I think that Italy is a great example for that, because in Italy, currently, there are 20 gigawatt of Agri-PV projects in the pipeline waiting for authorization, compared to 4 gigawatt of what we call traditional ground mount. The reason for that is that it takes 3 times more to get permitting for ground mount compared to Agri-PV. So again, with this understanding, many developers and many stakeholders prefer and push for Agri-PV. But in order to get these incentives and easier permitting process, there are also technical guidelines and requirements that must be fulfilled in order for these projects to be able to move forward. And what we see in terms of these technical guidelines, and here it's where it gets interesting, is that Agri-PV sites usually are limited in terms of coverage ratio. We usually see something around 40% or less. But this is something that is really important to understand. And again, in the next part where we talk about the solution, this is something that we really take into consideration. There are requirements in terms of the size, the physical size of the system, minimum height or pitch and distance between rows of panels. This is something that is also being regulated and required by policymakers, again, with the aim of making sure that agricultural production would be possible below or next to the PV system. Electric safety is something that we see more and more, and again, it's not really difficult to understand why when you have Agri-PV system installed on farmland where non-solar professionals work with heavy machinery and do farming work, electric safety must be ensured and considered. Layout and configuration, again, for Agri-PV, there are new types of or more new types of layouts. We see elevated systems. In some markets, we sometimes see vertical PV. Again, these new types of installations are also quite common in Agri-PV, and that's something that needs to be considered. And we also see O&M requirements. And the last thing is the requirement to allow the integration between solar and agriculture. And this is mainly done through requirements for preserving agricultural production. Policymakers determine what is the maximum reduction that they would allow in terms of crop yields. In many markets, we see that this will be around 30%. Monitoring and reporting, so there are specific requirements of what data should be monitored, and then the periods or the ways that are needed in order to report. There's also assessment and examination of this data. And again, this is basically what you see here, summarized the structure for how typical Agri-PV market would look like. And these requirements and this policy and regulation for Agri-PV basically creates what you see here on the screen. PV systems installed on farmland, elevated or in different structures and different types of layouts. And basically what you see here is just a few examples from SolarEdge Agri-PV projects from around the world, but this is basically how it looks when you comply with these requirements and with the regulation. So it might look a bit new for those who are not familiar with Agri-PV, but you see that it already works, and we have this is, again, just a few examples from SolarEdge Agri-PV portfolio. What you see here is sites that we already installed. So we have all different types of layouts and configurations, from vertical to single axis trackers. We have experience with different types of crops and different types of farming activities, and different types of climate zones and areas around the world. Now, with this experience, with our understanding of Agri-PV regulation, market forces, and requirements, we really understand that DC optimization is required. And the main reason for which DC optimization is so important in Agri-PV is that it allows to achieve these 5 benefits that you see here on the screen that are essential for the success of an Agri-PV project. And I'll explain in the next slide each of these benefits and why they are important. The first thing that we need to consider is that the solution must be able to achieve better land utilization and also ensure bankability. And second thing is to maximize energy production. Third thing is to improve O&M efficiency, because again, in these sites, it's more challenging to enter the site, and also in case that there is a problem with the PV system, to fix it or to analyze what the problem is. Safety is very important, so this optimization and our solution really maximize safety in these sites, and also to allow collection of data and research tools for the growth and success of the Agri-PV market. And I'll just give a few examples of why each of these benefits are crucial and essential for the success of Agri-PV project and the Agri-PV market and segment in general. So land utilization and project bankability. As I mentioned, Agri-PV projects requires different or new ways of thinking in terms of design. It's the main thing that is important to understand in Agri-PV is that, unlike other ground mount projects, where basically there is an option to do groundwork and make the land most suitable for solar energy production, in Agri-PV it's quite the opposite. The PV system must adjust or be adjusted to the existing situation on the farm or on the land. And this really makes it more challenging to design these sites, and not just to design, but also to predict how much energy will be produced. And this is a challenge in terms of bankability, because if you do a new layout, if you increase pitch, if you suddenly need to optimize the sunlight radiation between crops and the PV modules, then it really makes it more difficult to understand how many hours during a day you'll produce energy, and how many hours during a day will be devoted to produce crops. Again, this is something that must be addressed, and in the next part we will also talk about how DC optimization and the SolarEdge solution allows and tackle this challenge. The second thing is producing more energy. So with this optimization, we'll allow higher and increased energy production. But why it's important? Mainly because of the fact that you see here on this slide. In Agri-PV sites, we see more module mismatch. We see energy loss due to soiling, energy loss due to shading. This is something that we have in many of our many PV projects, but in Agri-PV, these factors are increased and even higher. We have few examples that really shows that with optimization and DC optimization and that tackles module mismatch, it's much more energy production is increased by a lot. In many of the Agri-PV projects, there's also use of bifacial modules, and there the mismatch is even higher. So again, this is something that must be taken into account and addressed when you design or think about developing Agri-PV project. Operation and maintenance is the third challenge and the third thing that that I mentioned as part of the benefit that we provide with DC optimization. So why is it important to focus on operation and maintenance? Mainly because, as you can see here in this site, Agri-PV projects are often elevated or installed in such a way that makes it more difficult for maintenance, because not just because it's elevated and because it's more difficult to get and see the problem, but also because it's installed on farmland and access to the site is usually limited. And we don't want to have maintenance teams within the farm going in and out and interfering with farming operations. So we must address and think about how to make O&M more efficient when we design and plan an Agri-PV project. Safety in Agri-PV, and I mentioned it at the beginning, is something that is really important due to the fact that in these projects we have non-solar professionals operating and doing farming work below high voltage systems or next to high voltage systems. We see that it's not just, and we see a lot of policy and regulation that's supporting that, but we also see that farmers in few markets really express concerns post-installation of Agri-PV systems on their farmland with regards to the safety and the safety of their employees and the safety of their machinery and the farm work. So safety is something that really must be addressed, not just in terms of, mainly in terms of the technology, but also in terms of training and education of the farmers and the farm workers that have access to the site. And the last thing is research tools and data collection. And again, here, when I say research tools and data collection, the reason for which this is very important, the reason for which we really address this in all of our Agri-PV projects is not merely in order to be able to say that Agri-PV is something that can work, is not merely for research purposes. Data is the basis for the growth of Agri-PV. In order to really allow the optimization, in order to really understand how to achieve both solar energy production and agricultural production on the same plot of land, we need to have data. We need to analyze and assess the amount of energy that is being produced. What are the impacts of the agronomic decisions or agronomic agricultural surroundings on energy production? We need to analyze this data and use it for improvement and for maximization in the next projects. So this was the last challenge that I wanted to talk about, and I'll now pass to Shiru to talk about our solution, the SolarEdge solution, and how DC optimization really helped to achieve these benefits.
Thanks, Noam. Can you guys hear me clearly? Hey guys, can you guys hear me?
I can hear you. I don't know if you can hear me. It's
Yes, I can. I don't have the presenter mode, Noam, so do you mind sharing your screen? I can just talk about it.
yeah, I can give you the presenter mode. Yeah.
All right, can you guys see my screen or not yet?
Yeah. I,
All right. Hey guys, Chiranshu Bhatia here. I'm applications engineer at SolarEdge. Today I'll be talking about our product line for ground mount and dual use solutions. Um, so real quick, I'm sure most of you guys are familiar about our products, but we have something called power optimizers. These are essentially DC-DC converters, which are paired with our inverters to provide you a complete ecosystem. I like referring SolarEdge as the Apple of our industry because every product works in sync with each other. Um, so I'd like to talk about the four key benefits of our products. The first one is optimized energy. So because we eliminate mismatch on systems, um, we usually tend to see around 6% more energy than traditional string inverters on our systems. Due to our longer string lengths and additional savings on BOS, we typically see in our projects anywhere between 50 to 60% more BOS cost savings. We also have our free monitoring platform, which gives you granularity and real-time data of your system. And Noam did touch about the safety features. So we did add a couple more safety features to our systems, and I'll talk about them in detail. Um, Moving on, I would like to show you guys the current offerings we have of our products. Um, so for the three-phase inverters, on the 208 side, we have the 10 kW and the 17.3 kW. On the 480 side, we have the 30 and the 40 kW. I'm sure most of you guys know about the synergy technology, but what that is basically a building block of our smaller inverters to make a bigger inverter. So on the three-phase synergy side, we have the 50 kW for the 208 volt segment, and then we have the 80 and the 120s for the 480 volt systems. So the 80 and the 120s are basically 2 and 3 units of the 40 kilowatt inverters combined together. We also have the 100 and the 110 kW. Depending on your interconnection requirements, you can choose the right product for your system. A couple of changes from our previous versions in our inverters have been higher DC-AC ratio. So now our inverters can go up to 175% oversizing. We also added integrated RS-45 AC and DC SPDs on our systems. We also now support both 3-wire and 4-wire grid connections. In addition to these features, we also have integrated fusing on the DC side. There are 25 amp fuses for each string, and we also support aluminum cabling on DC and AC side. For the 1000-volt inverters, which is this slide you see right now, we can go up to 60 modules per string. So it's typically twice or thrice the length of your traditional string inverter. So to summarize the benefits of our system, we have 175% oversizing. For the ground mount projects, if you guys have projects where you want to use DC combiner, we also have the DC single input flavor. And you guys can reach out to me or any of the applications engineer here at SolarEdge to get more information. PID rectification is another exciting feature in our inverters. We have built-in rectifiers which reduce the PID effects on systems. One of the amazing features about our products is the innovative pre-commissioning feature. And what that is if the AC grid is not available, installers can hook up a battery bank to their system and pair up their DC optimizers and keep the DC side ready for the PTO process. We also added thermal sensors on the AC and the DC terminal blocks to add more safety to our systems. And because of our modular design, we have a higher system uptime. So even if one of these synergy units go off, the other two are always working. So you never lose an entire inverter, even if one of the units fails. To talk more about PV safety, we are the leaders in PV safety, and one of our features, which we call the Save DC feature, is basically when the inverter shuts off, all our optimizers go down to a safe voltage of 1 volt. So it provides additional safety to your O&M people while they know that there's no risk of high voltages at the array level. In addition to that feature, we also have DC-AC surge protections, integrated arc fault protection, and temperature sensors on our optimizers. And I'll talk about that in the next slide. Just to highlight, we also are on the list of top 2 insurance companies, FM Global and Zurich. So now to talk about the S-Series optimizers, this is actually our new power optimizer. It's the S1200, 1201 series. The main difference between the 1200 and the 1201 is one's for ground mount, the 00 series is for ground mount, and the 01 series is meant for reflows. The best feature about this optimizer is that we added a thermocouple in this optimizer. So it's an additional layer of safety because of the incidents in our industry regarding connectors. So what this does is it senses the temperature on the connectors, and if there is a temperature rise, it's gonna shut off the inverters and cease production. So just an additional layer of safety on systems. Now moving on to our 1500 volt DC ground mount solution. We call that the TerraMax. It's a 330 kW inverter. It's not modular, it's one big unit. And one thing to note is it's paired with our H series optimizers. So it does not pair with the S series, it's only paired with the S series. Some key features of this inverter is we can go up to 200% oversizing on this inverter and up to 80 modules per string, depending on the module wattage. Similar to our commercial inverters, the 1000 volt inverters, we typically see anywhere between 50% BOS savings, and it comes with almost the same features as our 1000 volt inverters. Just to give you guys a quick overview of our products. So the 330 is rated at 330 kW, but can take up to 660 kW DC power. As I mentioned, it's paired with our H1300s, and you can basically hook up 2 modules, 2 650 watt modules in series, and can go up to 33 kilowatts per string. Here's a sneak peek. So one of the things we do here at SolarEdge is something called a project comparison, and feel free to reach out to us if you guys need one for your project. What this is basically an apples to apples comparison for a test case or one of your projects against a competitor to show you the BOS savings. And this is what you see on my screen right now. It's a typical BOS comparison. This was done for a 7.7 megawatt project. And what this shows you is the average BOS savings when you use SolarEdge on projects. So you can see that we save anywhere between 41 to 46%, again, depending on the system size. And we will be happy to run one of these for you or your installers if you guys have any questions. One of the recent upgrades we made to our monitoring platform is the SolarEdge CNI1. it's an exciting new software feature, and what this allows you is more visibility into your site performance. It has the new digital twin feature, which is pretty handy. It also has a heat map, gives you more capability on remote troubleshooting, and also, advanced remote capabilities when it comes to like grid connections. This tool is also handy when it comes to integrating EV chargers and battery systems on your projects. It's basically one site for all, and you can basically manage all your energy systems from this one post. So as I was mentioning, it gives you more granular data. You can look at your optimizer performance. It reduces the cost of any aerial inspections, which typical traditional string inverters require, because and it really provides you a less OPEX O&M cost on systems. So just wanted to show you guys a couple of key benefits, and I think this was my last slide. I'm happy to answer any questions at the end of this call, and I'll pass my screen to Mo to talk about SolarGik. Thank you all.
Thank you, Chiru, and I will go ahead and start sharing my screen, and you should be able to now see the full mode. So it's always a pleasure to go after Noam and Chiru because they do such a great job of giving us all the global background on what is happening in all the different regions and sort of the pros and cons of being able to present this. It's pulling from the wrong camera. Let's see if I can change the camera. There we go. So I'll introduce SolarGik and what we are doing to contribute to this global phenomena of Agri-PV. So
just I don't know if you can hear me, but you're not on presenting mode. So just so you know, sorry.
Meaning you do not see the screen, or it's not showing?
It's not showing in presentation mode.
Okay, let me see if I can get the third monitor now. Thank you for jumping in on.
So now we see only, oh yeah, perfect.
Okay, thank you. So SolarGik is a solar tracking solutions company. We provide both single access trackers and racking, as well as software solutions for both Agri-PV and general DG and utility scale projects. And the logos you see below are some of our key projects that we're doing, especially in North America, around agrivoltaics. You can see some of the leading universities and developers that we've been working on to push this out to the market. Now, you heard Noam, and you understand all the value that you can get out of Agri-PV. So why aren't we seeing tons and tons of these projects crop up everywhere? We should be able to see more of these. And the reason is because, as opposed to any other agrivoltaic project, you have a balance, right? You have a challenge of needing to balance between two different outcomes here: agricultural outcomes and solar energy outcomes / profitability. And that is what makes this so difficult. As Noam covered well before, the global regulation that we're seeing come out of Europe and slowly being adopted in North America is putting a lot of components in place that are geared to protect agriculture. Why is that? Because we know that, especially the developers on the line, right, and the investors, that the money for this is really on the energy side, on the solar energy side. And if we just left this to itself, we would probably see a lot of solar farms with not really much growing underneath. So by and large, the challenges and the regulation that we see globally are meant to really address two different things. One is the structure that we're using, to making sure that the structure and the racking will allow for continued ideal working of the farm with the standard machines that the farmers are used to using, and that we can balance the sunlight between the crops and the panels in a way that is optimal and measurable. Right? So those are the two challenges. How do we get the proper structures? And once the structures are up, how are we making sure that the crops and the panels are both being addressed? So to start with the aspect of foundations and racking, we're all in the solar energy business. When we think of a classic solar energy project, this is what we imagine: Nevada, Texas, California, Arizona, big, flat, square deserts. Doesn't mean that all of us on the line are from those locations, but this is what a classic solar energy project looks like, which is why this is what classic solar energy racking systems and trackers look like, right? Big, heavy, robust, long, and many, many flat square rows, one after the other. But as we know, that's not what a solar or Agri-PV structure will look like, right? You need to allow for the tractors, you need to allow for harvesting, for combines, for elevation, for farmer access, right? The structure needs to look very, very different, and that's one of the key challenges that needs to be addressed. And that's where our philosophy is a non-one size fits all, but rather let's focus on building blocks. Let's figure out how we design and create smaller, more versatile building blocks so that we can actually adapt them to the existing crops, as Noam described, rather than forcing the ground or the agricultural to fit to the trackers, right? And for that reason, we've developed the industry's shortest tracker. Now, when I say short, I'm not talking about close to the ground. I mean short as in each table of panels that's being moved by a single motor is much shorter. So instead of trackers that are 1 string, 2 string, 3 strings, even dual rows moving 150, 200 panels, each of our trackers of our building blocks is between 8 to 24 panels. Now, side note, if you're doing community solar, DG, other smaller projects, you actually see the benefits of power density, being able to conform to odd shapes, being able to elevate these structures for grazing, being able to fit the topology here, the topography with difficult slopes. That's all enabled through a much shorter and versatile tracker. Right, to give you a sense of what it can look like, I hope you can see the video moving. Right, this is one of our projects in Nevada. Now, not that this is exactly what an Agri-PV project necessarily looks like, but what you're seeing here is the racking's flexibility to adhere to slopes, to be raised in the air, and in a sense to be able to fit the contours of the land and whatever we choose to maximize for. Specifically, if we're looking at the Agri-PV projects, right, they're going to look much more like this. As you can see, unobstructed pathways for the machinery, being able to elevate them, whether it's 2 meters in the air like Italy, 10 feet in the air like in Massachusetts, or whatever the location requires in terms of the minimum regulation. We have the ability to raise these trackers high in the air to allow them to actually flip the panels if needed, right? And to do so without connections that would obstruct any of the work on site. In terms of the second challenge, and what is probably even more complicated, even though visually, right, building these structures in the air looks extremely difficult, it is. Being able to serve 2 masters at the same time is actually a big challenge, right? Being able to make sure that the panels are getting what they need and being able to make sure that the crops get what they need is probably the #1 challenge of Agri-PV, especially if you want to be able to do that in a transparent way. So the first thing we need to do, and Noam did mention this before, is begin with the collection of information, right? We need to be able to connect agricultural sensors into the crops. This isn't needed in every project, and we are not enforcing this. This is what we're doing with a lot of universities working in order to discover what are some of the best ways to address this in the different regions in which we're actually developing the projects. But the goal here is to collect the information, the photosynthesis activity, humidity, temperature, things like that from the crops, and then plug them into our SCADA in real time so that we can actually make better decisions that are balancing between the crops and the energy. Now, those of you who've been in the solar field for a while, you see this video running now, and you think, okay, this is just another tracker tracking the sun, doesn't look any different. But if you pay attention closely, you should be able to figure out that there's something else going on here. And if you haven't yet figured it out, it's the fact that you're not actually seeing any shading on the ground. And the reason you're not seeing any shading of the ground, because what you're actually seeing here are these trackers in a project with EDF, where we are actually in what we call anti-tracking. And in a sense, what we're running an experiment here is running a full day of trackers where all of the sunlight was being passed through to the crops. Now, obviously, no project is going to pencil if you do that every single day. But the main challenge that developers face is being able to quantify that and then use those specific numbers in their financial models in order to figure out ahead of time if the project will pencil. So what we've done is we've developed our own 3D modeling that can run these simulations beforehand. What we're doing now with, again, universities building these arrays and then testing and ensuring that the modeling that we've done actually matches up, right? And that we can, as opposed to most systems like a PV-Syst or a helioscope, who are fantastic about giving you the annual simulation, but they do not know how to do those calculations when you're not in optimal tracking throughout the year, right? Give you an example of what I mean. This is a project that we're doing with the University of Colorado State University and Sandbox Solar. What we did here with the university, we defined a growing season, right, for these crops between May and July. From sunrise to 11 a.m., they need full sunlight. Those are the optimal times for photosynthesis. And moreover, we want to make sure in the afternoon that they're not overheated by the sun. So we're making sure that the panels are actually protecting the crops and not letting the sunlight through to the plants. So what you see here on the right are the simulations of what the panel, the tracker looks like during growing season, right? It's an anti-tracking in the morning versus the square to the right of that, which is what would a tracker look like with no constraints and just maximum tracking. This in and of itself is interesting, but the real kicker here is the next slide. We were able to exactly quantify the reduction in energy needed for this scenario in Colorado in order to allow the crops optimal growing season between May and July, right? What you see here is we did this for 2 different pitches, pitch, i.e. the distance between rows, and we were able to quantify that in this scenario throughout the entire year, you're not going to lose more than 10% of production. Is that a challenge? Potentially, but now you got the land for cheaper, you got to cut the line in terms of interconnection queues depending on what the local regulations are, and those are exactly the trade-offs that we see happening in the world of Agri-PV. So what we look for here is the balancing of the light and the shading, and we've allowed developers to plug and investors to plug these numbers into their equations well ahead of the project to see if it pencils. So we did this. Now what? What happens if somebody wants to change something? The next challenge we're solving for here is the transparency challenge. We actually have more stakeholders in an Agri-PV project than we would ever have in a standard, regular investor-owned project. We have farmers who want to grow their crops. We have agronomists who have opinions on what the optimal seasons for these growing are. We have regulators, right, depending on the country, that need to make sure that you really are growing crops, that you are hitting the annual yields you committed to in order to get this incentive of Agri-PV. And obviously, last but not least, yourselves, the developers, the asset owners, who want to make sure that they're actually getting the payments on the energy. What happens if the farmer needs to go 3 times that day to do some kind of activity or harvest? Does the developer know? Does the agronomist know? What we're providing here is a SCADA solution that is a central platform collecting all the information in real time, allowing for this transparency, This is where we're uploading the shading programs. This is where everybody can see who did what, so that if something needs to change based on the sensor decisions by asset owners or farmers, so at least we can now have a mechanism for getting everybody aligned afterwards, whether that's through financial payments, etc. We now can at least solve for that centrally in terms of the control over all of these systems. To give you a sense of what this looks like and to finish up and open up for Q&A, these are a few of the structures that we've built globally. You'll see different heights, grazing, over vineyards, over lychee, over mango, over grapes. We've done this over quite a few different types of crops. We've been collecting the information, and we're absolutely thrilled to partner with more developers, asset owners, EPCs looking to do this. I can easily be reached at mo@solargeek.com. And just a quick thank you to Krannich and SolarEdge for inviting us, SolarGik, on to present today. And that's it for my presentation. Happy to turn it back for the Q&A.
Thank you so much, Mo. Hope you guys can hear me. This is Varsha. I just wanted to jump in here and help with the Q&A. Let's see, we have a few questions coming in. If you guys want to leave anything else, please feel free to put it in the questions section. Mo, there is a question for you from Swaroop. Doesn't short tracker tables also mean more trackers and therefore more cost considering large projects?
So it is true that shorter tables does mean more trackers, right? But what I didn't get a chance to get into today is because we have smaller motors, each one of our trackers is moving fewer panels, so we can dramatically reduce the amount of steel. 70 to 80% of a cost of a tracker is steel rather than motors, right? And that's actually a big change and shift that we're seeing now in the industry. So we are using more motors, but we're typically significantly lighter in terms of the weight and the amount of steel, and hence the cost relative to the trackers that we're familiar with on the market. So that is a purposeful trade-off that we're making, one that we believe benefits not just Agri-PV, but tracking overall. So that's the same methodology that we use for community solar, DG, etc.
Got it. Thank you, Mo. That's helpful. There's a question from Joe. He's asking if there are any research projects in the Midwest of the US, such as Illinois, for dairy farms, even for cranberries or vegetable crops and fruit trees. Is that a question for Noam, probably? Or would you be able to answer that?
Noam, I'll let you jump in. I can throw some answers in. Oh, I think Noam had to jump to another webinar, actually.
Yes.
So I'll answer for him, even though this is his forte. The answer is yes, there are. We've actually done a few grazing projects, both not necessarily in the Midwest, but globally. There are quite a few. I think there's in the Northeast, in Boston as well, or somewhere else in Massachusetts with other forms of grazing. So I'm assuming that's the question around dairy is, can you have cows underneath the structures? And the answer is you can. And I do believe that there is significant amount of projects with berries. Part of the benefit of working with a company like SolarGik or SolarEdge is the global reach. So we have seen projects with those crops. They might not have been in Illinois, but they are in terms of that crop suitability, whether it's sun loving or shade loving, and the trade-offs that you need to make in order to address that. I'm sure Noam can send more information in a follow-up for that.
Yeah, that sounds good. Thank you. There is a couple more questions here. Ralph is asking, what are the crops that aren't ideal for Agri-PV typically?
I'll answer that as well then, I guess, if Noam's not on. The answer is the more shade loving a crop is, the better it is for Agri-PV, in that there's less of a trade-off. There's less of a necessity to balance between the sunlight. For example, we've seen in some desert areas where places that are too arid or too sunny for standard agriculture, suddenly when you're adding on a structure above it, you can grow things in places that you previously couldn't. A few of the examples that I was showing when I was going through were projects from Israel in locations that without the shade, you pretty much couldn't have grown anything. So ideally, you're looking for crops that are shade loving, right? And then there's less of a trade-off. That typically will also change based on the region in which you're in and whether or not you are a hotter or colder climate, and in the sense what you're compensating for, right? So that will really be more of a regional question, and Nevada and Massachusetts won't necessarily have the same answer, even if it's the same crop. It will depend a little bit on the local situation.
That's great, thank you. Chiru, just a couple of questions for you here. I know we're running out of time, but would you recommend using 480 volt AC systems or 600 volts and over for ground mount? For ground mount projects?
So you guys can hear me, right? It really depends. It's a really installer preference, but as a designer, I would always recommend using a 1500 volt DC and a 600 volt AC system, because you tend to have higher BOS savings on systems with bigger and higher voltages. So as an installer for ground mount, I would definitely be looking at 600 volts.
Okay, got it. And how does SolarEdge specifically mitigate module mismatch in systems? I know you went through this in a little bit detail, but can you answer that?
Sure. One of the best analogies I give is traditional string inverters have strings of 17 or 18 modules. Here at SolarEdge, our strings are basically 2 modules behind every optimizer. So that's one of the ways we mitigate mismatch, because you're basically comparing 2 modules versus 18 modules. Traditional string inverters, one of the modules goes down, it brings the entire string down. But in our case, because of optimizers, they're always maximizing energy harvest from systems. So that's one of the ways we mitigate mismatch in PV systems.
Sounds good. One last question, and this is for Mo. How are the elevated trackers holding up in high winds, and what is the SolarGik warranty period on the trackers?
So I'll start with the second part. The warranty period is the standard industry warranty, which is 10 years on the structure. Obviously, that's extendable as needed. The way we're holding up in those winds is because of wind safety. So like any other tracker, we've done wind tunnel testing, CFD, and what we do is when there's strong winds, the trackers will go into safe mode. In fact, with advanced analysis that we're doing through satellite imagery, our trackers can even go in a little bit before if they're now casting or forecasting harsh weather. That can also be controlled remotely as needed. But the light track, the reason trackers have more steel is not because of the wind. It's because they need to move more panels with torque. So that's the reason they tend to be bulkier. In terms of dealing with wind, all the trackers are going to move into safe mode. Some trackers stow at different angles, but by and large, it has to do with moving into the angle that lets the wind pass over the tracker rather than having a sail open to the wind. And we've done all the testing necessary for it.
Sounds good. Yeah, that's helpful, Mo. Thank you. There are a few more questions here, but since we're out of time, I can promise that we will get back to you over email shortly, Joe, Swaroop, and Ralph. And you will also get a copy of this recording along with some resources that we will send via an email, not next week, but the week after that. So please be on the lookout for that. And Mo, Chiru, and Noam, thank you so much for the insightful presentation. And thank you, Krannich and Julia, for hosting us. And thanks, everyone, for attending and for your time today. We appreciate it. Have a great one, everyone. Bye.
Thank you.